Today's my topic is, we want to share some experience, how we're working with our, in the custom and a partner in China, and help them to improve the performance on Spark. So the title is how to boost 100 times performance for real world application with Apache Spark. My name is Jiangang Duan, and actually this session is co-authored by me and Grace. And Grace has the other session, so we just, I will deliver this one, and she will deliver the other one on the streaming bench. And she will help me, on the Q&A session if you any further question I can't understand. Okay. So this is the agenda we will talk. First, we will do some very simple self-introduction, and we will talk about, why we are here, the problem we meet when we help our custom tuning all this Spark performance. And based on the problem, I will talk about, what we did in the past 1 or 2 years, and we will, what we plan to do in the next maybe several months to solve the problem. So after that, I will, give several examples to, try to give you some, idea, how we're helping our and the custom and our partner to solve the real problem, perform problem in the product environment. And in the end, it's a summary. So I want to, this is in general teamwork. I want to thank all these guys in the Intel big data team. So they did all this real work. So really thanks for them. So we're actually from China. We're based in Shanghai. And we are open source team. We have 20 software engineers dedicated working on all these open source projects. They are almost 100% developer the Spark and help the Spark become more and more better. So we're starting working on Spark pretty early. That's when it's still a research project in UC Berkeley. And also one thing we did pretty well is we're working very closely with all this custom in China. And interesting in China is actually if you listen to the the keynotes this morning, they gave several excellent results, excellent product case in China. For example, Tencent and Ali. So actually, China internet company, they are very aggressive to use Spark in the early days. So we actually, Intel have a very good relation with them. We're working with a lot of them, including some of them here. And actually there's people, but we're actually working with the China team. So most of the things we're talking today is actually, for the story, we're working with those custom. So we trying to several different things. We are working on the real-time in-memory technology. That's one thing we are focused on. And we're trying to solve, do better job to process both the structured and unstructured data. And we also have some team working on the cloud part. And because we have custom, they are really looking for how we can manage their data center, how we can integrate their big data cluster with their existing web server database cluster together. So we have the other team working on that. And we're working very closely as I mentioned earlier, that with Berkeley, all this university, and actually Intel have both a cloud computing and a big data lab with very famous school in states like MIT, Berkeley, CMU, all this stuff. So that's a simple introduction. So what's the problem? So actually, one thing we also did in China is we're running a Spark meetup. We already in Shanghai actually. Spark is very popular in China today. We already have 4 meetups since last winter. And every time we have more than 100 or 200 people come to the meetup, share all these license, talking about the issue, all this problem. So we did in the early days this year, we did a simple survey. So in general, we are trying to understand for all these kind of people, what's the key challenge for them for Spark. So this is the thing we learned from them. So by the way, actually, most of the people go to the meetup, they are really people, they want to use Spark in their product environment. So I remember 17% of the people actually is from the internet company. They actually use Spark in their product environment. So in general, there are several. Spark is great, right? So that's the reason a lot of people want to go to Spark. But one thing we hear a lot about, in general, Spark is still in the early phase. It's not as robust as traditional Hadoop system. So we see several, the top challenge we heard from the people is something like, it's not so easy to use compared to Hadoop. It's not reliable enough. The performance sometimes have the issue, and the stability is the issue. So in general, the things that's a typical problem for every open source software at early phase, right? People starting to adding new feature, and there's an early acceptor. They try to build in a cluster, but it still takes time for some company, other company, to try to increase the quality of the code. And there's a more and more pilot when people try to move from the class size from 100 to 1,000, 1,000 to 2,000. Things become better and better. So we hear several things. So the left figure is actually from the survey of the Meta people, and the right all these words is actually from when we're talking with all these internet companies. So there are several issues. Talking about something like optimal memory. So that's one keyword we hear from the customer that is sometimes it's difficult to configure the parameter for the pick up the right partition size and decide the right memory size for each executor. So sometimes we will run into the optimal memory issue, and the Spark will try again, try several times, and it's failed. That's one issue, and also that some issue like the memory control resource monitor. So I have the QR number. Actually, you can scan this. This is a URL for the meetup, and you can get to the survey result on this web page. But content is still Chinese, so we are trying to translate that into English. So what Intel did? So Intel trying to do several things I want to introduce here. So first, we want to define a better workload. I will talk about that. We have a workload called HiBench. And the second thing is, our customer come to us and ask us, can you guys, I don't know if you guys can providing a tool that we can, troubleshooting, identify the bottleneck and the problem, so we can know how to improve the performance for the code cluster. So we actually have a profiling tool. We call that HiMeter. And the other thing I will talk about, we actually have a dedicated cloud server. We're doing regular, upstream, Spark performance testing. We actually have a website where we will publish data every week. So, so that's actually one request from our customer and also from the developer. So one of the concerns is people have the concern that maybe because there are so many releases every week, so people want to make sure that they can monitor the performance change very well, and the customer can prepare if there's any performance regression. So I will talk more about that. So at the end of the talk, I will talk about some real custom case, the real optimization we did to solve the performance issue. So this is HiBench. So HiBench actually have already a very long history, and the first time we're talking about this is almost 5 years ago. So it's actually a micro workload, and it's composed of 10 small workloads. So it's easy to understand and easy to analyze. So one new thing we recently did is we just announced version 4.0 in the first half of the year, just 1 month ago. We're actually adding Spark support in this workload. So currently you can, we're porting all these 10 workload with the 3 different language implementation, including the Scala, Java, and also Python. So we actually use this workload in our daily life to analyze the performance. So there's a URL you can take. So the other thing we are doing now, we are trying to adding a new streaming bench workload into the category. We will have the other session in the afternoon talking about the workload. The workload name is stream bench. In the user case category. So if you are interested, you can go to that session also. So in the second half of this year, we will increase the next generation HiBench, and we will also including HiBench into that. So HiMeter is so in general, it's a profiler, it's a tuner. We want to help the people, the cluster administrator, the developer to understand where's the performance, where's the bottleneck, how to improve the performance. So we're actually writing a small framework that composed of a lot of a small agent and collecting all this information across the cluster. And it's very lightweight, and it's actually we actually do the pretty good design to make it scalable. This is some figure to show you what HiMeter can do. It's kind of like if you listen to Kate's talk just now, it's a little similar to what she's doing in the Daybreak Cloud. But we're actually providing a script and a GUI. You can deploy this into your cluster. So on the left side, you can see we will auto detect all this staging in the Spark execution path. So we can detect all this job, all this stage, and all this task. On the other side, on the right side, above the above part, you can see that actually we will collecting all this system perform data. Including CPU, memory, disk out, and network. We will show both aggregation data and also the per node data. So with this, the administrator or the developer can easily to understand where's the bottleneck. They can do some compilation, to see which phase or which stage, in this stage or in this phase, the CPU or the network is a bottleneck. So we actually try to add in some. Based on our own experience of adding some rule here. So you can actually, if you see on the page, you can see that actually we can detect, where's the performance issue. We can give some, suggestion based on our previous define some rule, known rule. So this is a performance portal for Apache Spark. So as I mentioned, that we actually currently have a dedicated cluster. That's 10-node cluster with latest Xeon processor, and also it's pretty good cluster. So a dedicated cluster for the regular performance testing for Spark. So every week we will automatically get the code from the GitHub, and also doing the performance testing. Currently we support two workloads. One is the HiBench, there is the Spark Perf, and there's a URL at the bottom of this page. If you are interested in the performance data, you can subscribe on this mail list. So in that case, you can get the email report every week reporting the latest Spark performance. So I show a figure here is talking about in last 5 weeks, what's the performance look like. So actually the lower is better. We take the Spark 1.2 as a baseline, and compare the performance, the latest release performance to the Spark 1.2. So we take the compilation time as normalize the compilation time as final result. So actually the lower is better. The negative means the performance is better than previous. So you can see that actually in latest release the performance become a little better. And on the right side, in the website, we're also providing some detailed breakdown. So you can see this is an example to show all this HiBench workload. So one thing you may mention that actually the k-means performance is now very good because it's almost takes twice the time to finish the same job. So we're currently working with Jiangang together, try to understand why this happened. Maybe there's some coding issue or maybe some config issue. So it's just an example to show you. And in some pages here, actually, for example, in the work week 22nd, you can see that actually for some data there's not available because actually in that release, some of the queries, Spark Circle have some bug, so we cannot complete this running job. So next, I want to show you with all this benchmark workload and profiling tool, I want to show you some example. We're working with real custom and help them solve the performance issue and improve the in general performance. So I will talk about four user case. So this one is, so one thing we learned from, in the internet company actually, Spark is famous for the machine learning, right? Because in general, its design is very good for the machine learning. You're putting everything in the memory, and the computing can be very fast. But in reality, actually, in China, at least in China, in the internet company, 90% of the user model for Spark is still, they try to replace Hive today. So we talk with a lot of customers, and most of the issue customers told us and want to working with us is actually, can you help, solve this query issue, So that at least now, according to our experience, the most component for them is still Spark Circle. So this example is talking about, in reality, we are trying to, doing multi-table join. So the left figure is the original design. So you can see that actually, if we want to join 4 tables with the same key, so actually, in previous design, we need to do several, split the whole join process into several phases. So in every phase, we need to generate some time table and also, result in a shuffle process. So, so one of the problem actually, I gave you example on the right side. You can see that here I gave you example. In these 2 tables, we do a 4 out of join. So one of the example here, you can see that actually 4 out of join sometimes can generate a lot of unbalanced state. Here you can see that in some cases they generate a lot of none. So the issue for that, if you have an imbalanced state, right, when you do the partition, do the shuffle based on the key, in this case based on this new key, so there's a high possibility will result in a skew. So if you do have a skew, generally that is very difficult to you setting the partition number, and it's very easy to get the out of memory issue. The other issue for this problem is actually, you have to do several, 3 more, shuffle. So shuffle is actually very time consuming because of all this network issue and all this, acceleration, deceleration, right? So we try to avoid that. So we're actually working with a custom, and we providing a new patch. It's a Spark PR 78771. So we try to, instead of we doing all this join step by step, so we actually can doing we take the join into one phase. So in that case, we can, in general, that remove all this unnecessary shuffle cost and also avoid the disk go. So the real performance testing demonstrated this patch can, have twice performance better compared to previous, query plan. Second one, so as I mentioned that when we have one of the customers that one thing you try to avoid this goal is you can always do a better application design, but in reality that's not easy to happen. So one challenge we hear most from the customer is actually when they try to jump to large page, it's almost take a very long time due to the all this either of the GC or all this out of memory issue. Sometimes it takes a long time to do the GC. Fortunately, you can have enough memory, you can cache all this data, but sometimes it's just impossible for the executor to get all this required memory. So it's just the Spark just failed. So one of the tricky thing you can do here is you can increase the partition number. So in general, you can increase the partition number, and in that case, every reducer can have a less memory pressure. So sometimes you can have the application run successfully. But that's very time consuming. Our experience tells us usually you need to try several times, and you can get the good result. But for that issue, if you have a very high disk pool, that's also cannot solve. induce the partition number cannot solve the problem because one reducer maybe have a lot of data needed to process. So this is a previous implementation. This is actually if you use previous our customer use HashJang. So in HashJang case, actually, the left side is one table doing the Jang. So first you need to generate a hash map, and you need to have all this data into the hash map. So if you look at all this K and all this K and all this compact buffer to store all this value, so in that case, it consumes a lot of memory space. So this is very easy to generate all this GC issue or auto memory issue. So one thing we did actually, we introduced a short mode Jang. So so this is have two patch. One is for inner Jang, the other for outer Jang. So I gave an example here. It's very clear that if you're doing the short mode Jang, you can use in two iterator and just go through the K by one. So in that case, you don't need to generate a very big hash map. So in that case, actually, you can save a lot of memory and reduce the memory pressure a lot. So actually, a lot of our customers take this patch and solve their problem in the product environment. So this page actually gave some more details. So first, in last page I talked about we replaced HashJang with short mode Jang, right? So in that case, you can reduce the memory pressure. You can make the job done quickly and easily. But on performance side, actually, if you think about that, HashJang usually have a better performance than if the memory is big enough, right? If the memory can hold all this data, so actually HashJang usually have the better performance than the short mode Jang because it doesn't need all this short operation, all this kind of stuff. So this page actually showing several several testing results we do for this in our lab. So you can see that on the X side is actually the partition number. On the right side is the combination time. So the lower is better. So the origin line is actually is HashJang. Please ignore the 200 partition for the HashJang because actually original that Mate has a patch to do the short-based stuff on the map side. There's a criteria if the partition number is too slow, that patch will not turn on. So actually, so the performance is so low because that patch is not automatically turned on. But you can see that actually, just look at the 500 and 1000 perform node. You can see that compared to the green line, so actually the hash mode Jang have a little better performance. So we do the other thing, try to improve the performance. We just turn on the, we're working with Cloudera, Intel working with Cloudera, CSI working with Sandy, have a short-based Staffel patch. That's a Spark 2926. So with this patch, we can actually close the performance and increase the performance to 20% and close the performance gap compared to HashJang. So we recommend actually most of our customers just move to short mode Jang because it's much easier to configure the memory and avoid the outer memory issue. This is user case 3. So this is actually machine learning work. Actually, this is one bug. So we just previously used backend and graphics to do the graphs analytics. So we're checking all these memory sets. You can see that actually, there's a known issue in the backend application. So the memory space will continue to increase. Although that actually after each iteration, the previous RDD can be freed. But the previous there's bug, so you can see that the memory continue to increase. So we actually did a patch, and so with this patch, actually, now the application can free all this unused memory stuff. So actually, we recently have a blog talking about how we can tuning the JVM parameter to have the best GC behavior and the memory utilization. So it's on the Daybreak's blog, Daybreak's.com blog. So if you're interested, you can go to the URL. And also, actually, our colleague also will talk about this. We have the other session. I think it's tomorrow. We will give more detail about to explain this, how we did all this smart tuning. Because in general, JVM parameter tuning is very important for Spark performance. Okay, this is last one. So most of our customers, they actually running Spark in the Yang today. Or sometimes actually they have their own customized Yang, very similar to Yang, but it's not upstream Yang. So each executor will copy one job jar in a Yang situation. So one of the issues we actually finding that is because there are so many executors will running on the same of the same node, and so when we try to distribute all this, sending all this, deliver all this jar file to all this executor, it take a long time because we need to sending to all these different executor in the same host. So that's actually it's not necessary because all this node, all this executor host is running on the same physical node. So in general, in series, we can just send one copy and share this copy to all this node. So I gave several examples to explain this problem. So you can see that actually this is in the below figure. This is actually the high meter figure. So you can see that at the beginning of the running phase, there's some vertical line that's just split all these different phase and the different stage. So you can see that in previous implementation, you can see that actually at the beginning it takes a long time for all this jar file to distribute to all this executor, and you can see that actually the network bandwidth and also this bandwidth is not very high. So we did the other patch. Actually, the patch number is PR number is 2713. So in general, we can just send one jar file for all this co-located executor. So you can see that now, actually the first stage is so short, so the two lines merge together. So you can see that the CPU increased very quickly, and also that we didn't see a long waiting and the runtime time. So actually we can get almost 10 times speed up in the bootstrap phase. So that's summary. So in general, we are the Spark team inside Intel. We based on our talking and our working experience with our customer, we think that there are still several challenges, including scalability, reliability, and stability. And I introduced this in this PPT, talking about the project we are working on, try to solve this problem. And thanks for all this China company, we work together. They are very kind of like working with together to solve this problem. And we would like to Intel want to spend more time in general working with the community. So if you are a Spark user and you're running some Spark cluster, you have some performance issue, we would like to learn that. And if that issue is very typical and important, we can allocate some resources to fix that. And we have a demo booth, and in that demo booth, we will demonstrate the high meter and ASP. So if you have time, please go to our demo booth. We have some people who show the live demo there. I think that's all. I can take one question. Please. Sorry, I cannot hear you.
The title of the talk was that how to do 100x improvement.
Yes. Oh, okay. So actually, I didn't listen all this data. So actually, for several of these testing we are talking about, we can generate almost more than 100 performance improvement, actually. I didn't see all this performance data here. Okay, at wrong time. Thank you.